Prime factorization. Definition. Prime factorization is finding which prime numbers should be multiplied together to make the original number. Note: there is only one unique set of prime factors for any number. There is no other possible set of prime numbers that can be multiplied to make that number. To find the prime factorization, we need to know the multiplication tables, and we should know the first few prime numbers, which are 2, 3, 5, 7, and 11. Prime factorization helps us find the square root, the cubic root, the least common multiple, or LCM, and the greatest common factor, or GCF. The best way to find the prime factorization of a number is to start dividing it every time by the smallest possible prime number, and the result of the division should be a whole number, without a remainder. Stop dividing when the result of the division equals 1. Draw a vertical line, and write the original number on the right. The prime numbers should be written on the left, and the result of the division should be on the right. Example 1. Find the prime factorization of the following numbers, 12 and 588. Solution. For the number 12, we start examining the divisibility rule of 2, which is the smallest prime number. The last digit is 2. Therefore, 12 is divisible by 2, and the result of the division is 6. Then, we examine the divisibility rule of 2 again with 6. 6 is an even number. Therefore, 6 is divisible by 2, and the result of the division is 3. Now, by examining the divisibility rule of 2 with 3, we'll find that 3 is not divisible by 2, without remainder, so we move to the next smallest prime number, which is 3, and examine the divisibility rule of 3. We'll find that 3 is divisible by 3, and the result of the division is 1. So we stop here. Prime factorization of 12 will be as follows. 12 equals 2 times 2 times 3. Or by using exponents. 12 equals 2 squared, times 3. This is the only set of prime factors for 12. There is no other possible set of prime numbers that can be multiplied to make the number 12. For the number 588, 588 is divisible by 2, and the result of the division is 294. 294 is divisible by 2, and the result of the division is 147. 147 is divisible by 3, and the result of the division is 49. 49 is divisible by 7, and the result of the division is 7. 7 is divisible by 7, and the result of the division is 1. Prime factorization of 588 will be as follows. 588 equals 2 times 2 times 3 times 7 times 7. Or by using exponents. 588 equals 2 squared, times 3, times 7 squared. Note that even if we didn't start with examining the smallest prime number, we'll get the same prime factors because there is only one unique set of prime factors for any number. But the best way is to start with the smallest prime number. Let's try again with 12. 12 is divisible by 3, and the result of the division is 4. 4 is divisible by 2, and the result of the division is 2. 2 is divisible by 2, and the result of the division is 1. Prime factorization of 12 will be as follows. 12 equals 3 times 2 times 2, which equals 3 times 2 squared. Rearrange the numbers. 12 equals 2 squared, times 3. Factor tree is another way to find the prime factors. We start by picking any two positive integers greater than 1, which the result of their multiplication equals the original number. Then we do the same with those positive integers. In each branch, we stop when we have a prime number. The prime factorization represents the multiplication of all the obtained prime numbers. Let's try the number 12. Let's pick 3 and 4, since 3 times 4 equals 12. 3 is a prime number, so we'll stop in this branch. For the other branch, we'll use 2 twice, since 2 times 2 equals 4, and then we'll stop because 2 is a prime number. Prime factorization of 12 will be as follows. 12 equals 3 times 2 times 2, which equals 2 squared, times 3. Thank you for watching MathMix YouTube channel. If you found this video useful, then please subscribe, like, comment, and share.